Today we're going to talk about the quadratic formula. By the end of this video, you'll be able to solve quadratic equations over the set of complex numbers using the quadratic formula. So we've already talked about the standard form for a quadratic equation. That is that you have ax squared plus bx plus c equals 0. You have to have your quadratic in standard form to be able to use the quadratic formula. The quadratic formula is given on your note sheet. It is also on your SOL formula sheet. This should be something that you saw in Algebra 1. You have x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And there are two solutions because you have the plus or minus. So one of your solutions will be using plus and the other solution will come from using the minus. So another important vocabulary word is discriminant. This tells you what type of solutions the quadratic will have. The discriminant is the part inside the square root, the b squared minus 4ac. You should always calculate this first. That way you don't make silly algebra mistakes. So we've got a few different situations here. If you find the discriminant and you get a positive number, then there are two different options. The discriminant is a perfect square. Then you have two rational solutions. If it's a positive number but not a perfect square, you have two irrational solutions. If your discriminant equals 0, then you have one rational solution. And if your discriminant is negative, it's less than 0, you have two complex solutions. So use this to help you double check your math. If you get a discriminant that's negative, you know you should have two complex solutions. If you don't have two complex solutions at the end of all of your math, then you made a mistake somewhere. So let's try a few examples. So our first example is x squared plus 6x plus 14 equals 0. So this is already in standard form. It might be helpful for some of you to write out what a, b, and c are. So a is 1, because that's the coefficient of x squared, b is 6, and c is 14. So I'm going to calculate the discriminant first. So that's b squared minus 4ac. So that gives me 6 squared minus 4 times 1 times 14. And then you can type that in your calculator. And you end up with negative 20. So we know right away, since we got a negative number, that we should have two complex solutions. So let's go ahead and finish the problem. So the quadratic formula is x equals negative b plus or minus the square root of the discriminant, which we just figured out, all over 2a. So we can go ahead and plug in b and a there. So we get x equals negative 6 plus or minus square root of negative 20 over 2 times 1, which is just 2. So last class we talked about simplifying radicals. So that's where this becomes important. So I'm going to do some work off to the side. If we have square root of negative 20, I know that the largest perfect square that is a factor of 20 is 4, so I can break this up into square root of 4 times square root of 5 times square root of negative 1. Square root of 4 is 2. Square root of 5 can't be simplified, and square root of 1 is I. So this will simplify to 2I square root of 5. So I end up with x equals negative 6 plus or minus 2I square root of 5 over 2. And that is almost our final answer. We have one more thing that we can do to simplify this. So I'm going to draw this little heart here. If all three numbers in that heart can be divided by something, then go ahead and divide them. So all three numbers can be divided by 2. So I'm going to say that my final answer is x equals negative 3 plus or minus I square root of 5 over 1, which I don't need to write. So that is my final answer. Let's look at the next problem. We have 3x squared plus x equals 2. So I need to write this in standard form first, which means I need to subtract 2. Then I can write out what a, b, and c are. Okay, then I can go ahead and find the discriminant. Which is b squared minus 4ac. Then again, you can use your calculator to just type that in, see what that equals, and you get 25. So it's positive, and it's a perfect square, so we should have two rational solutions. So now we can go ahead and plug this into the quadratic formula. X equals negative b plus or minus square root of the discriminant over 2a. So I know the square root of 25 is 5, and I can go ahead and multiply 2 times 3. So since the discriminant was a perfect square, we no longer have a radical in our answer. So we need to split this up so we can do the plus solution and the minus solution. So this gives you 4 over 6, which is 2/3. This gives you negative 6 over 6, which is negative 1. So our final answers are x equals 2/3 and x equals negative 1. Now, you can check your solutions just like you did for completing the square. If you go to the app, Polysymult, Polynomial Root Finder, leave all the settings the same way you had them for completing the square. Then you're just going to type a, b, and c in the calculator. So we have 3, 1, negative 2. Solve. And I get negative 1 and 2/3. Again, that should be a way to check your answers, not a way to do the math completely on the calculator without showing any work. All right, we have x squared plus 13 equals 4x, so again we need to set it equal to 0. Remember, with standard form you should always have the x squared term, then the x term, then the constant term. So a is 1, b is negative 4, and c is 13. So our discriminant is b squared minus 4ac. Now, when you're typing this in the calculator, there is a difference between typing negative 4 squared and parenthesis negative 4 squared. The second one is the correct way of writing that. So make sure you use parentheses when you're squaring a negative number. So we get that our discriminant is negative 36. So it's negative, so we're going to have two complex solutions. So we can go ahead and fill in the rest of the quadratic formula. So we have negative b, since b is already negative, it'll change to positive, plus or minus square root of the discriminant over 2 times a, which is just 2. So square root of negative 36, square root of 36 is just 6, so this will be 6i. And again, we can divide all of these numbers by 2, so we need to go ahead and do that. So we end up with x equals 2 plus or minus 3i. Now this problem, we have 2x squared minus 6x minus 1, so it's already in standard form. So let's go ahead and write out a, b, and c, which are 2, negative 6, and negative 1. So if we find our discriminant, you have b squared minus 4ac. And when you type this in the calculator, you end up with 44. So that means we are going to have two irrational solutions because 44 is not a perfect square. So if we go ahead and fill this in with the rest of the quadratic formula, we get x equals 6 plus or minus square root of 44 over 2a, so 2 times 2. Now, square root of 44. 44 is 4 times 11, and 4 is a perfect square, so I can rewrite this as the square root of 4 times square root of 11. Square root of 4 is just 2. Square root of 11 can't be simplified. So square root of 44 simplifies to 2 square root of 11. So again, draw your little heart, double check. All of those numbers can be divided by 2, so I'm going to go ahead and divide them by 2 and get 3 plus or minus square root of 11 over 2. So that is our solution. We have one more problem to take a look at, and that's a word problem. It says the equation for an object's height, s, after time t seconds after launch is given by this equation. S of t equals negative 4t squared plus 97t plus 75. When does the object strike the ground? I'm going to graph this real quick just so we have an idea of what we're dealing with. So we have negative 4, and I'm going to go ahead and just type x squared. All right, and then because these are larger numbers, you're definitely going to have to zoom out. Your regular window will not be sufficient. So I'm going to click Window, and I'm going to adjust these. Change X max to about 100, and count by tens, and change Y max to 100, and count by tens. Okay, so if I zoom out, or if I change my window again, if I change my Y max because I can't see the top of the parabola, whoops, I'll make it 1,000. Whoops, and count by 100. Okay, so we have something that goes up and comes back down. And we're looking for when does it hit the ground. So in this situation, the x-axis represents the ground. So we want to know, when does the graph hit the x-axis? So we're just going to set this equation equal to 0 because the y value is 0 when it hits the ground. It's 0 feet off the ground. And solve. So we have -4, and I'm going to change these to x's for right now. And that's what we're trying to solve. So a, -4, b is 97, and c is 75. So again, I want to find my discriminant first. So I have b squared minus 4 times a times c. Then you can type that in your calculator, and you get 10,609. So you can check and see that is actually a perfect square. So we're going to have two rational solutions. So let's go ahead and do the quadratic formula. We have -b plus or minus the square root of the discriminant over 2a. So if you use your calculator, the square root of 10,609 is 103. Over -8. So now we can split this up into our two solutions, one with the plus and one with the minus. And then if you type those in your calculator, the first one gives you -3/4, and the second one gives you 25. So since this is a word problem, we need to check and see if our answers make sense. T is the number of seconds after it's launched. So is it going to hit the ground -3/4 of a second before it's launched? That doesn't make any sense, because that means we would be going backwards in time. But it could hit the ground 25 seconds later. That makes sense. So our final answer is that it hits the ground 25 seconds later.